Hello everyone, and thanks for taking the time to check out this video. For today's SKS presentation, we're going to be turning our attention to a fairly niche aspect of SKS stock construction, which is the metal reinforcements present in military production wooden stocks. That list will include bayonet-cut reinforcement pins, crossbolts, and wrist bolts. The primary goal of this presentation is to offer a technical explanation of why these parts are included in the design and what exactly they are doing. As a secondary goal, I hope to round out the presentation by offering a few practical examples of how understanding these more subtle details not only helps us better appreciate the weapon as a whole, but actually equips us to make skillful repairs when necessary. As always, this video is brought to you without sponsorship or rattling of a tin cup. However, if I do earn your engagement today, I'd sincerely appreciate it if you took the time to simply click some YouTube buttons before leaving. Without further ado, however, let's get right into it. We will start with the bayonet-cut reinforcement pins, as these are pretty straightforward. Just about every SKS enthusiast will have noticed these, but we don't always take the time to appreciate precisely what they are doing. In fact, it's quite rare in my experience to even hear them described in correlation with the bayonet cut, which is very much what they're there to reinforce. The main thing to understand here is that the single weakest point on the SKS stock, at least independent of any internally or externally generated forces, is the wood between the bayonet cut and the barrel relief cut, or more specifically still, between the bayonet cut and the cleaning rod relief cut, which is located at the bottom of the barrel relief cut. From the factory, the wood here can be as thin as 1.5 millimeters or about 1/16 of an inch. The bad news is that's not a lot of wood. However, the good news is that, again, this area of the stock isn't really subject to significant forces. Still, it is a weak point, so we should do something about it. Technically, we could make the area thicker, however, that would be less resource efficient, not to mention it would add a noticeable amount of weight over the length of the stock. A much simpler solution is to simply reinforce this weak point with a steel pin, which will relieve most of the stress that could theoretically find its way into the area. Of course, given that most SKS pattern carbine stocks are rather old at this point, you may still find hairline fractures, flaking, or general thinning in this area. However, that notwithstanding, function-inhibiting failures originating from this point are still extraordinarily rare. Takeaway, the pins work. Once again, progressive deterioration in this area seems to be driven more by time and environmental conditions rather than an inability to tolerate kinetic energy. Either way, now that we understand what these reinforcing pins are doing, we can also understand why some SKS stocks have 2 of them and others only have 1. Generally speaking, this directly corresponds to the pattern of bayonet cut present in the stock. Cutouts for blade pattern bayonets are rather short and deep, meaning that the wood in the weak point is extremely thin. However, the length of that weakness is relatively short, right around 3.5 inches. The best way to reinforce this pattern of cutout is with a single pin placed just rearward of the relief cut's terminus. Cutouts for cruciform or spike type bayonets have a completely different geometry in that they are long and shallow. This of course means that the wood in the weak point is actually significantly thicker. However, the length of that weakness is nearly twice as long at about 6.5 inches. In this case, it makes more sense to use 2 reinforcing pins, one of which will again be placed immediately rearward of the relief cut's terminus, and another one this time going straight through the weak point near the tip of the forend. It should also be noted that the cruciform or spike type bayonet relief cut creates a second relatively weak point, which is this area here. It's not terribly unusual to discover hairline cracks here, but once again, that first reinforcing pin should be doing a great deal of work in delaying, if not preventing, such cracks from developing. And just as one last note, earlier I said that generally speaking, the number of reinforcing pins directly corresponds to the type of bayonet cut in the stock, and I chose that verbiage carefully because there are always exceptions. Albanians, for example, use a single reinforcing pin despite utilizing a spike type bayonet. This may be due to the secondary weak point being much stronger on Albanian examples, or it may be because Albanian military decision making is notoriously eccentric. In any case, we've covered what those pins are and what purpose they serve, so let's move on to the next component. Moving rearward, let's turn our attention now to the crossbolt, also commonly called the recoil-lug. For whatever it's worth, I think this is one of the more poorly understood components on the SKS pattern carbine, and I'll freely admit this is an area where I had to work through some misconceptions of my own. When asked, most people will tell you that the purpose of the crossbolt is to provide a steel-on-steel interface by which recoil forces can be safely distributed from the barreled action to the stock. This makes a whole lot of sense conceptually, especially to those of us who are familiar with the historically defined concept of a recoil-lug. After all, the Mosin pattern M44 carbine, an immediate predecessor to the SKS 45, does include a very similar looking component in the same location that does function exactly as I just described. So do a wide variety of other military production rifles tracing well back into the 19th century. When it comes to the SKS, however, there is a glaring problem with that explanation. As much as the SKS Crossbolt might look like the recoil lugs of previous designs, the way it interfaces with the SKS receiver is quite literally reversed. Rather than create a bolster behind the barreled action, which is where it would need to be in order to soak up recoil forces as we traditionally understand them, the SKS Crossbolt actually locks into place in front of the barreled action. In other words, this component is not actually functioning as a recoil lug, at least according to the most common historical definition of that term. So what's actually going on here? Well, the function of the Crossbolt is still intimately connected to recoil. It's just not as simple as transferring acute recoil energy from the action to the stock. More precisely, the Crossbolt is stabilizing the action and preserving its harmonics under multiple recoil impulses. I'll try to keep this part as concise as possible, but it's important to understand that the recoil forces generated by a gas-operated autoloader, like the SKS, are more complex than the recoil forces generated by a manually operated battle rifle. When you fire a manually operated rifle, a bolt-action Mauser for example, you experience a single recoil impulse. This is caused by the controlled detonation of gunpowder and is best described as an equal and opposite reaction to the bullet being forcefully accelerated in the direction of the target. As the mass of the bullet is pushed forward, the bolt face is shoved rearward. Because the bolt is securely locked into the action via a hardened steel interface, this energy has nowhere to go but into the barreled action, then into the stock, and finally into the shooter's shoulder. And that's it. There's really nothing more to say for bolt action recoil. Now, everything I just described also happens in an SKS. At the moment of cartridge detonation, the bolt is securely locked into the receiver. Just like in a Mauser, a sharp recoil impulse will flow through the locked bolt into the barreled action, then into the stock, and then into the shooter. And this accounts for most of what the shooter will feel, by the way. However, in reality, it's only the start of a chain reaction of impulses which the firearm itself will experience over the next 70 or so milliseconds. Again, the SKS is a gas-operated auto-loading firearm, which means that some of the rapidly expanding gases used to propel the bullet are redirected from the barrel into the gas system. This causes a lot of things to happen very quickly. The gas piston is launched rearward, causing the gas piston extension to strike the bolt carrier while simultaneously compressing the gas piston extension spring. As the bolt carrier flies rearward, it unlocks and picks up the bolt, vents gas out of the chamber asymmetrically, and compresses the recoil spring. As the recoil spring compresses, some of the kinetic energy of the bolt carrier is converted into elastic potential energy, while some of it is directed through the recoil spring back into the barreled action. While all this is happening, the gas piston extension spring forcefully pushes the piston back into its forwardmost position in the gas tube. And finally, the bolt carrier strikes the rear of the receiver, pushing the whole receiver back and allowing the elastic potential energy gathered in the recoil spring to be unleashed as kinetic energy again, accelerating the whole bolt carrier forward until it slams into battery, pushing the whole receiver forward. And listen, I'm sorry I'm not a 3D animator because I know that not everyone will have the frame of reference to follow everything I just said. For the purpose of this video, however, you do not need to be tracking all of those individual interactions as long as you understand that the SKS is really getting knocked around under recoil. There are quite a few forces pushing in different directions, and there's a lot of disjointed reciprocating mass. And that's where the Crossbolt comes in. Technically, it serves a few functions. However, I would argue its primary utility is in stabilizing the barreled action's center of gravity in all of that chaos. Whether the action is rocking back, rocking forward, or trying to do both at the same time, it is supported by a steel-on-steel interface. Additionally, the Crossbolt establishes a balanced counterpoint between the front and rear interfaces of the stock and action. It creates gentle tension required for unimpeded harmonic vibration, and it does these things in a way that requires minimal fitting, a significant priority for the militaries that issued and maintained these weapons. Finally, it should be noted that because the Crossbolt is actually bracing against forward movement of the action within the stock, and the final recoil impulse of a cycling SKS is in the forward direction, the Crossbolt ensures that the barreled action of the SKS will naturally return to the exact same position within the stock after every shot. All of these functions contribute to better accuracy for the rifle, longevity for the stock, and convenience for maintainers. I know that one was a little long-winded, but hopefully now you have a better idea of what Crossbolts are and what purpose they actually serve. Either way, let's continue to move rearward on our rifle. And here we are at the final stock reinforcement component, a piece which I call the Wristbolt. Technically, we could also call these Crossbolts. In fact, they are very similar in size and construction to the Crossbolts we discussed previously. However, the function they serve is more similar to bayonet-cut reinforcement pins. Rather than stabilize the action against recoil forces, Wristbolts simply exist to reinforce a potential failure point, in this case the wrist of the stock. For the purpose of this video, we can think of the wrist of the stock as being on the opposite side of the failure point spectrum from the thin portion of the forend, which we discussed at the beginning of the video. The wrist is inherently quite robust, however, it is also subjected to the most violent internally and externally generated forces of normal SKS usage. It is not unusual for hairline fractures to develop in this area, which will typically run parallel to the direction of recoil. These fractures can be caused by poor stock fitment, subpar wood quality, a particularly energetic service life, environmental exposure, or any combination of factors thereof. Wrist bolts can be used to repair cracked wrists. However, more commonly, they are used preemptively to reinforce wrists before cracks can ever form. And this is probably as good of a time as any to point out that wrist bolts generally only appear on a small percentage of SKS stocks, Soviet laminate stocks specifically. This makes a great deal of sense when we think about it. While laminate stocks do have some advantages over hardwood, an obvious weakness they introduce is a tightly packed row of what are essentially pre-established fracture points in the wrist aligned with the direction of the primary recoil impulse. This didn't necessarily have to be an issue, but given the suboptimal quality of laminate production in 1950s and 60s Russia, it was. To the Soviets' credit, however, they recognized the problem and applied a solution in the form of wrist bolts. This was a technology they had already heavily utilized on Mosin pattern rifles, so translating it to laminate SKS stocks was a relatively simple endeavor. So that's what wrist bolts are and why they exist. In short, they mitigate a weakness which can technically be present in any SKS stock, but is disproportionately problematic in Soviet laminate stocks specifically. So now we've covered exactly what all of these metal reinforcements are and what functions they serve. But before we wrap up for the day, I want to give a few examples of how that knowledge can help us be more capable SKS owners, particularly in the realm of preventative stock maintenance and repair. I get a lot of emailed questions pertaining to these subjects, and I'm hoping that moving forward, I can use this video as a reference for some of those inquiries. With that in mind, let's start by covering two practical takeaways from bayonet-cut reinforcement pins. First, the thin material between the bayonet relief cut and the cleaning rod relief cut is a potential weakness on any SKS pattern carbine, and it may be in your interest as an SKS owner to periodically inspect this location. Although the area is not subject to significant forces, age and environmental exposure alone can lead to cracking, flaking, or thinning. If you do discover these processes occurring in your own rifle, you may want to consider painting the area in a thin coat of 2-part epoxy resin. This will essentially plasticize the wood and delay, if not completely interrupt, any further deterioration. Additionally, this is what I would consider to be a minimally invasive repair procedure and therefore appropriate for many SKS pattern carbines. Second, the concept of reinforcing pins can be applied to other locations on the SKS, as well as similar areas of relative weakness on completely different firearms. Using the same basic principle, it is possible to stabilize cracks and relieve stress in thin segments of aging wood. Here's an example of an orphaned M38 Mauser stock in which I've installed my own SKS-inspired reinforcement pin. I was able to purchase this stock at a sizable discount due to the presence of an unstable crack in a thin portion of wood. Not only did I repair the crack, but I relieved the stress which caused the crack in the first place, and 7 or 8 years later, it is still rock solid. Obviously, this is a more invasive repair procedure, so I'm obliged to encourage enthusiasts to apply good discernment in identifying which stocks are and are not good candidates for such measures. Sometimes preserving history means locking a firearm up in a climate-controlled glass box, and sometimes preserving history means installing a steel pin in a 100-year-old rifle stock such that it can keep doing the thing it was designed to do. It falls on us as enthusiasts to know where to draw that line. I can't make that decision for anyone other than myself. Moving on to some lessons we can glean from the Crossbolt, I'll use this as an excuse to answer two of the more common SKS-related questions I get asked. First, sometimes people end up with an SKS pattern carbine that, for whatever reason, no longer has a crossbolt, and they want to know if it is safe to shoot. Short answer, yes, it is perfectly safe to shoot, as in you aren't putting yourself or anyone around you in physical danger. Long answer, you are absolutely inviting accelerated wear on your stock and should expect degraded accuracy. Of course, my recommendation to you would be to source and install a replacement crossbolt, but if for whatever reason you absolutely cannot, you may want to consider glass bedding your action. This is a different means of stabilizing your action under dynamic recoil, and it may replicate the repeatability that the Crossbolt provides. Second, I get a lot of questions about hand-fitting SKS stocks to barreled actions and whether or not you can adjust the recoil-lug specifically. Short answer, yes you can. Long answer, it depends what you're trying to accomplish, and sometimes there's a better way to do it. When fitting a barreled SKS action to a stock, there are basically 3 areas you need to pay attention to. For the purpose of this video, I will call them connections 1 through 3. Connection 1 is the interface between the tip of the forend and the lower handguard ferrule. Connection 2 is the interface between the crossbolt and its corresponding ledge in the receiver. And connection 3 is the interface between the protruding locking tang and the rear inlet of the stock. I am of the opinion that in a well-fitted SKS, you want to prioritize a mild tension between connections 1 and 2, such that even if you were pushing the barreled action and stock in opposite directions, you would not be able to slide even a sheet of paper between the crossbolt and the receiver. A tiny bit of play here is not the end of the world, but again, I have found that a mild tension between these 2 points seems to positively affect accuracy. Presumably this is because these 2 points stabilize the barrel, not entirely dissimilar from how a British SMLE forend uses deliberate pressure to increase accuracy. Here we're looking at what I would consider to be poor fitment at connection 2. This particular example happens to be more of a reference piece and collector's item to me, so I have no plans to fix it. However, if this was a more practically oriented setup, I would absolutely correct that fit. Personally, I'm a little less picky with connection 3, and basically I just want it to be as tight as possible, such that it isn't competing with connection 1 for tension with connection 2. As such, I find that a gap of a few thousandths here is totally normal. In any case, if you are trying to adjust the fitment between your stock and barreled action, I would encourage most people to start by dialing in that tension between connections 1 and 2, and then assessing where you're at with connection 3 and making small adjustments if necessary. If the connection between 1 and 2 is too loose, you can tighten that up with shims, or you can extend the forend slightly. Shims could theoretically go between the forend and the lower handguard ferrule, but I think focusing on the interface between the crossbolt and the barreled action makes more sense. You can achieve great fit with crushable aluminum shims in this area, although of course once these are in place, you're going to want to avoid disassembling that rifle to avoid the shims coming out again. If you are interested in a more permanent solution, here's an example of what that can look like. In this case, I cut my forend back slightly, bolted on an oak extension, hand carved the correct geometry, and carefully removed material until I had the exact length I was going for. If by contrast, the connection between 1 and 2 is too tight, such that when you try to rock your receiver and stock together, they just won't go together, obviously you need to remove material either from the crossbolt or from the forend. I'm personally of the opinion that removing that material from the tip of the forend can yield a more professional result. However, I have seen both work. And again, once you've got that tension between connections 1 and 2 dialed, hopefully connection 3 is already within an acceptable margin, but adding or removing material here is pretty straightforward should that be indicated. And last but not least, let's apply what we've learned from wrist bolts. Honestly, this is the easiest one. If you have unstable fractures developing in the wrist of your SKS pattern carbine, or any other rifle for that matter, you've got 2 choices. You can stop shooting, or you can fix it. If you decide to fix it, one effective option to consider is to install a wrist bolt. And this doesn't have to be a surplus Soviet wrist bolt, by the way. It can be a piece of threaded rod, a dowel and wood glue, or really anything which will reinforce the wrist perpendicular to the direction of recoil. Personally, I tend to favor threaded brass rods for this application. In fact, one of the first videos I ever posted on this channel was of me experimenting with blind drilling and recessing wrist bolts in such a way they would not be externally visible. Obviously, I tried to put my own spin on it, but at its core, this is a technique I learned from studying the SKS. Just as another example, here we're looking at a Type 53 carbine, and on this particular specimen, I repaired a cracked wrist with a wooden dowel. Simple and effective. And that's about it, guys. Of course, there's a lot more that can and hopefully will be said about SKS stocks, but I think I've hit the subjects I wanted to cover today. I hope I've successfully made my case that understanding the minutia of SKS stock reinforcements is not just mechanically interesting from a historical perspective, but also quite practical for those of us who shoot old guns regularly and sometimes need to maintain them. Unsurprisingly, when we do our best to understand how historical firearms were built in the first place, we can usually find all the answers we need in order to keep them running. And with that, I am going to call it for today, guys. As always, I hope you found this video entertaining, informative, or at least worth the time you spent watching it. If you are new to this channel and enjoy this type of content, don't forget to click some YouTube buttons and consider checking out my SKS playlist. Lots of good information in there. Other than that, thanks again for taking time to check out this video, and I hope you have a great rest of your day.